which is distance between points. The first two topics should be a review. Oh, 21, I'm sorry. 21. 21.1. The distance between points. And basically what we talk, I'll derive that equation for you. If you have a straight line, and you have 2 points, and you want to find the 2 points between them, I'm going to derive that equation. This is the first point, right? This is the x value for point 1. This is the y value for point 1. This is the x value for point 2. This is the y value for point 2. So what is the distance from here to here? What's that distance? That's x2 minus x1. And what's the distance from here to here? Yep. y2 minus y1. If we use Pythagorean's theorem, remember that? This is C, this is A, this is B. It said what? C squared equals A squared plus B squared. C is actually the distance between the 2 points, isn't it? So that's the distance. So the distance squared equals A. A is what? x2 minus x1, and you got to square it. It says square it. And B is y2 minus y1. And you're going to square it. And if you just want to solve for the distance, not the distance squared, how do you get rid of that 2 here? Square root. And that's the equation you see in our book, that the distance between 2 points can be found by using this equation. x2 minus x1 squared plus y2 minus y1 squared. So that's really where the math came from, the derivation behind it.
Now, what? Oh, you're going to read that.
Do you need to understand the derivation? No, as long as you know how to use it. Could you write this one first and this one second? Absolutely.
Why are you keeping everything out of the square root? Can't you just take away the...
Can't. That's addition. When you have a square root of a plus b, you can't break it down. If it was multiplication, you could. Division, you could. Not addition, subtractions. So now here's an example. Find the distance between, I'm going to give you 2 points. Somebody pick a point. Give me an x and a y value. Go ahead. 1, 3. And somebody else pick a different value.
5, 6.
5 and 6. It really doesn't matter which one we call point 1, which one we call point 2. Yep. If I call the first one point 1, then this is the x value for point 1. This is the y value for point 1. This is the x value for point 2. This is the y value for point 2. I could have called this one x1, y1, x2, y2. I'll be fine. The distance between the 2 points is the square root. Let's plug in the numbers. What is x sub 2?
5.
5 minus, what's x sub 1?
3.
Try again. 1. The other 5. Y sub 2
6.
minus y sub 1. 5 minus 1,
4,
square it.
16.
6 minus 3,
3,
square it.
9.
Wow, you guys good. Came out the square root 25, which is what? 5. Now we can try this 20 times, but we'll never get a whole number for an answer. Tyler, did you schedule a time on my office door? There's a sign-up sheet. Did you put it? Yeah, you did something? Okay. So the distance between the 2 points is 5. That's how we find the distance between any 2 points.
Question.
Yes?
Plus minus or only 5?
No, just plus. Distance, notice distance always positive value. The distance will never be negative.
Can't be. It's
Yep.
impossible. Vertical law of physics to have a negative distance.
Now, what else we have in that section? We'll look at that picture there. Another topic in this section, as I said, some of the stuff is actually repeat. So the next topic, don't get excited, the first 2 sections are like review, then it gets new stuff, is the slope, which we use the letter M. If we use the same line here, the same picture here, the slope is what? The rise over the run. So that's what? Y sub 2 minus y sub 1 over x sub 2 minus x sub 1.
And that's section 2.
So if I want to find the slope again, find the slope for the same 2 points. Slope of the line that passes through one and 3 and 5 and 6. Remember in the previous example, I called this one x1, y1. I'm going to change it now. I'm going to call this point x1, y1. No reason. This is x2, y2. My answer is not going to change. So what is the slope? y2 minus y1, x2 minus x1 is the rise over the run, the change in, sometimes I write that change in y over change in x. That's what delta means in math. When you see that little triangle in math, means delta, change. The change in y over the change in x. So what is y sub 2? 3 minus what's y sub 1? 6. X sub 2, 1 minus x sub 1, which is 5. 3 minus 6, negative 3, negative 4, negative over negative, positive 3 over 4. That means if we were living in a house that has a slope of 3/4, for every 4 yards you go horizontal, your yard goes up how many? 3. Notice my slope is positive. There's 4 possible outcomes to a slope. You could have these are positive slopes. Why we call them positive slope? As x increases, as you go to the right, what happens to the y value? Increases. Goes in the same direction, like a plane taking off. As you're going forward, the plane is rising. A negative slope is backward. These are negative slopes. As you go to the right, as x increases, what happens to the y value? Decreases. The plane is landing. Usually, if you're flying from Springfield to Orlando, the plane takes off, that's positive slope. Has to rise, right? Well, Bradley.
Oh, okay.
Then what happens? Goes flat,
Mhm.
then it goes down. That's the negative slope. What about in this area?
5 to 0.
That's a zero slope. Why? Because the definition of slope is the change in y over the change in x. Did the y value change?
Nope. No.
No. So any line that's horizontal has a zero slope.
You missed the feet
Oh yeah, slop.
there. Zero.
We got a zero slop there. So these are zero slopes. Anything that's horizontal, you have a zero slope. So usually when you go on vacation, you have positive slope, zero slope, negative slope. Every once in a while we hear about undefined slope. That's when the plane drops out of the sky, straight down. You don't want to be in that one.
Or just fly straight.
That's a vertical line.
All straight.
Any vertical line has undefined slope. These have undefined slope. Why we call them undefined slope? When you look at the zero slope, the slope is the change in y over the change in x. So if I pick 2 points like these, let's say the x value here was a -2 and this is a -1, right? So the change in y is going to be 0. The change in x is going to be, depends if which one I call x1 or which one I call x2. It's either 1 or -1. It really doesn't matter which one. But 0 divided by anything is what? 0. Now, this one, why we call it undefined slope, let's say I pick this value to be 2 and this is 0.
X is 0.
The slope here is the change in y over the change in x. And that'll be 2 divided by 0, and you can't divide by 0. That does not exist. That's why a vertical line that goes up and down has no slope, because you are dividing by 0. The run is 0. Horizontal one, because the change in y is 0. The rise, there's no rise. Now, what else we know about slope? You can look at two lines without graphing them, and I can tell you if the two lines are parallel or perpendicular. By the way, just to take you back to trig. Where's my picture? Let me take you back to trig in case you forgot about it. Let's say this is the line. I make a triangle here. This is the change in y, right?
Mm-hmm.
This is the change in x. Let's call this angle theta. First, what's the slope, m?
Changing one over changing X.
Good. Now let me take you back to trig. What's tangent theta? The opposite over the adjacent, right? What's the opposite of this triangle? What's the adjacent? What do you know? The slope is really the tangent line, tangent of the theta. That's just for fun. Going back to trig. Now, if I said to you, we have two lines. Line 1, this is L1, line 1, passes through two comma 4 and 5 comma 7, you want it? Okay. Line 2 passes through, minus 1, minus 2, and 1 and negative 1. Are these two lines parallel? I don't even want to graph them. Are they parallel? Are they perpendicular? Or neither? Parallel? How do we know if they're parallel or not without even graphing them?
They have the same slope.
Very good. The slope of the first line has to equal the slope of the second line. So if the slopes are the same, they are parallel. So we can go and calculate their slope and see if they are equal. I'll do that in a minute. My next question was, are they perpendicular? Without graphing them. Perpendicular means, by the way, cross at 90-degree angle. Like an intersection on the road at 90 degree. How do we know if the two lines are perpendicular?
It's the
M1
negative
is
second.
1 over M2 minus.
Well, the rule says M1 times M2 is negative 1. Or M2 is minus 1 over M1. Either way. If you multiply the two slopes, the answer is minus 1. They are perpendicular. Or the slope of one or the second one is negative 1 over the slope of the first one. Either way, it's the same thing. We're just playing with the math. And if it's not this, it's not that, it's the other option. It's neither. So let's look at the problem I gave you here. What is the slope of the first line? Let's label these x1, y1, x2, y2. Is going to be 7 minus 4 over 5 minus 2. 7 minus 4, 3, 5 minus 2, slope is 1. What's the slope of the second line? Let's call this x1, y1, x2, y2. Be minus 1 minus a minus 2, right? Over 1 minus a minus 1. That's minus 1 plus 2 over what? 1 plus 1. That's 1 over 2.
Neither.
Are they parallel?
Nope.
No. Why? 1 does not equal to 1/2. Are they perpendicular? We said no. Why? Because if I multiply 1 times 1/2, it does not equal to minus 1. That's a half. 1/2 does not equal to minus 1. So that's neither. It's not parallel. It's not perpendicular. They probably cross at one point, but it's not a 90-degree angle, and it's not parallel.
So if we were doing it in the book, Professor, in the computer will give us the option neither, right?
Yes. They'll say parallel, perpendicular, or neither or neither. I'm looking to see if the midpoint, usually when we talk about this, the midpoint is mentioned here, but it's not here. I don't see it. Not there. That's the end of section 21.1.